If you can remember that in the atmosphere we have seen there is a kind of discontinuity or pause layers like tropopause, stratopause, mesopause. These are the layers of transition where one layer is ending, another layer is starting. Similarly, in the earth crust or in the below the earth surface structure, there are multiple layers found. These are called as the discontinuity layers or discontinuities in the earth's layers. So there are total 5 different discontinuities you can find out in the earth crust, not earth crust, in the whole earth. So here the very first discontinuity you can see here is the Conard discontinuity. What is Conard discontinuity? This Conard discontinuity is between the upper and lower crust. So that particular layer which is differentiating the upper crust and lower crust, that is the Conard discontinuity. Then coming to the second discontinuity, that is Moho discontinuity. This Moho discontinuity is found between the lower crust and upper mantle. So this is the lower crust and this is the upper mantle area. So this particular discontinuity which is differentiating the both the lower crust as well as the upper mantle, that would be called as Moho discontinuity. Then we have the Rapeti discontinuity. Rapeti discontinuity, that is find out between the upper and lower mantle. So this is upper mantle and this is the lower mantle. So in this particular zone, you can find out the Rapeti discontinuity. Then we have the Gutenberg discontinuity. This Gutenberg discontinuity you can find out in the lower mantle and outer core. So this is the lower mantle zone, this whole zone, yellow zone, and this is the outer core zone. So in between this particular area of the lower mantle and the upper core or outer core, you can find out the Gutenberg discontinuity. And then we have the Lehman discontinuity. Lehman discontinuity you can find out between the outer core and the inner core. This particular layer would be the Lehman discontinuity. So the 3 are most important here: Conard discontinuity, Moho discontinuity, and Gutenberg discontinuity. The Rapeti and Lehman also you can remember if they will ask someday, so you can answer also. The Conard, Moho, Gutenberg already asked in the multiple examination, so remember it carefully. Now let's see the next thing in the lithosphere, that is geochemical composition of the elements. If you look at the geochemical composition of the elements, like different kind of categories of elements you can see, where the multiple elements are grouped in one category. So the first example here is the lithophiles. Which elements would be called as lithophiles? So simply those elements which majorly find out in the lithosphere or the crust elements. So lithosphere is what? Lithosphere is crust. So that elements which is majorly found on the lithosphere, that can be called as the lithophiles. So lithophiles here would be the silicon, aluminium, and iron. These are few examples. These are the rock-loving elements. Then we have the chalcophiles. Chalcophiles would be the elements. These are combining with the sulfur. So the elements which are reacting with the sulfur, that would be copper, zinc, calcium, and we have silver, magnesium. So because these are reactive with the sulfur, these can be called as the chalcophiles. Then we have the siderophiles. Siderophiles are those elements which abundantly find out in the core zone of the earth. So in the core zone of the earth, we have already seen the nature of the earth core is Nephe nature. So Nephe nature, nickel and iron. So that would be the siderophiles, because nickel and iron majorly find out or eminently find out in the core zone. Then we have the atomophiles. Atomophiles are those elements which are majorly found out in the atmosphere or in the gaseous form, like oxygen. Then we have nitrogen, argon. These all are atomophiles kind of elements. So these are the 4 categories of geochemical elements. So remember these names. Sometimes they ask in the examination, which elements are the chalcophiles? So in the option, they can provide the elements which are reactive with the sulfur, the elements which reacts with the oxygen, the elements which reacts with the maybe any other thing, maybe none of the above. So remember what are these groups of chemicals. Now, that was all about the all different layers of the Earth that we have completed. Atmosphere we have completed, hydrosphere we have completed, lithosphere we have completed. Now we are moving ahead to the next portion of this particular unit, that is meteorology. Meteorology is very prominent topic of Unit 1. Multiple questions you can find out in every year's paper, every semester's papers from the meteorology alone. So be cautious while you are reading the meteorology. You can find out multiple questions from the catalyst as well. You can see the past papers, and a good portion of questions you can find out from the meteorology. So here, very first thing we have to read here in the meteorology, that is the classification of the areas or classification of the weather phenomena. This is called as meteorology scales. So how we can define a particular meteorology phenomena, or how we can say of the scale of the phenomena. Suppose it is taking place in a very small area, so we can say that that is very small area kind of meteorological phenomena. Then if suppose the affected area by that particular phenomena is very large, suppose whole India is affected, maybe any one particular state, full large state is affected. So on that scenario, we can say that the phenomena which is affecting, that is in a larger scale. So how we can define the different phenomena in different scales? That we can do with the help of meteorology scales. So here you can see that in your screen, there are total 4 different scales, which are categorized by 2 different things. One is time, another one is distance. Suppose time duration is high, so again there would be higher scale phenomena, you can say that. If distance, covered distance is high, so again that is a higher scale phenomena. So any one of them it is crossing, so the scale is also going to be up. So here you can see that there are total 4 scales. One is the micro scale, then we have meso scale, then we have macro scale, and after that planetary scale. So here the micro scale is the smallest phenomena, and the planetary scale is the largest phenomena. So here in the micro scale, you can see that first according to the distance. According to the distance, if that particular phenomena is taking place below the 100-meter area, or up to the 1 kilometer area, 1000 meter or 1 kilometer, both are equal. So either that phenomena is taking place below the 1000 meter or below the 1 kilometer, that would be under the micro scale phenomena. And time duration categorization here would be that phenomena takes place in hours to day. That can be finished within few hours. Maybe it can take 20 hours, 23 hours as well, but not more than 24 hours. A day means 24 hours. If it is crossing the 24 hours periods, then it will go to the major scale phenomena. But here, this is not above the 24 hours period, so that would be the micro scale phenomena. The example of such phenomena in the atmosphere, you can see that there is a turbulence, or there is a boundary layer phenomena. Now, what is the boundary layer or turbulence phenomena? So simply understand it with the vertical mixing of air. If there is a vertical mixing of air, the below layer is going above, the above layer is going below. So that vertical mixing is continuously taking place in the micro scale phenomena or in the micrometeorology. And that phenomena is called as turbulence. So if that turbulence or the boundary layer is taking place, that would be under the micro scale phenomena. Then coming to the second scale is the meso scale. Now this is for the 1 kilometer area. Now this would be, you have to add zeros. How much? 3 zeros, 1000 kilometer area. So from the 1 kilometer to 1000 kilometer, that all phenomena would be the meso scale phenomena. And the time duration here would be in days to week. So more than 24 hours at least required. And in this more than 24 hours, it should not exceed the 7 days phenomena or the 1 week of time period. So that would be all under the meso scale phenomena. Example of these are tornado or hurricane, you can say. So tornadoes generally come in the tropical countries like USA and Northern America, Southern America. These takes place. Here in India, we don't see tornadoes very often. Then thunderstorm, very heavy rainfall with the storms. That would be the thunderstorm, or with the very high wind, you can say it, as well as very high wind movement. If these all phenomena are taking more than 1 day time period, these all would be in the mesoscale phenomena. More than 1 day time period, but less than 7 days or 1 week of time period. Then coming to the third scale, that is the macro scale. So here this would be in 1000 kilometer more than to up to the 10,000 kilometer. This would be the macro scale phenomena. Macro scale phenomena is also called as synoptic scale phenomena. And the time duration here would be weeks to month. For example, cyclones. Multiple times in the newspaper or TV, you can see that there are different cyclones are forming or coming from the Arabian Sea or maybe Bay of Bengal. And the effect of these cyclones takes place more than a week, sometime 10 days or 15 days. So these are the macro scale phenomena or synoptic phenomena. Once the cyclone forms, it will be there, or the movement will be there up to the 7 days or more than the 7 days. And it can take or go up to the 1 month as well. Not 1 month, 1 month is a too much high duration, but more than a week you can say, and that's why this is under the macro scale phenomena. Then planetary scale. So here the last scale, that is more than 10,000 kilometer area. So that would be in the planetary scale for the whole globe scale. If I give you an example like El Nino, La Nina. El Nino, La Nina are the you can say large scale weather phenomena, due to which the one region of the world suffers from very heavy flood and another region of the world suffers from very heavy drought. And the opposite will happen in the La Nina. So both the phenomena, El Nino and La Nina, both are global phenomena. The main affected area is the Southern America area, Peru region, and the Indian subcontinent region, our Indian region. So every time after a few years, there is one side it is heavily flooded and one side it is heavily facing drought. So that is El Nino and La Nina phenomena. In El Nino phenomena, the Indian subcontinent is in the drought case, and in the La Nina phenomena, the Indian subcontinent faces the flood case, and the Peru region faces the opposite of that. So because this is taking place in a very large area, and this is a global phenomena, in every 4 years or 5 years, this takes place generally in the globe. So this is a kind of global phenomena or planetary phenomena. This is the meteorological scales, and all these four scales. So all the meteorological phenomena or weather phenomena come under either of these scales, any of these scales, every phenomena. Now let's see what kind of questions they form from the meteorological scales. In the past years papers, you can find out tropical cyclone occurs on. So tropical cyclones occurs on which phenomena? So first we have micro, second we have meso, then we have the macro or synoptic, and then we have the planetary. Planetary examples are only two, El Nino, La Nina, and above that we have the macro scale or synoptic scale, under which the tropical cyclones also come. So here you can see in the previous slide as well, tropical cyclones are under the macro scale phenomena. Macro scale is also called as synoptic scale phenomena. So here the same thing is asked, tropical cyclones occurs on what? Synoptic scale phenomena. D is the right answer. You have to remember as it is written in the slide, previous slide. Another type of question they can ask you, they can tell you the any meteorological scale, and they will ask you about the range of that or time duration of that, what distance it is covering or what time duration it is covering. In the options, also remember that you are not going to find out the exact value. The values would be different, and you have to find out the most realistic value or most nearby value of that particular actual value. So this type of questions you can find out multiple times in the past papers in the catalyst as well. So here it is asking about the range scale represents mesoscale motion in atmosphere. So very first scale is the micro scale, which is less than 1 kilometer. Second scale is the mesoscale, which is less than 1000 kilometer, less than 1000, or you can say 1 to 1000 kilometer. So here you have to find out that option which is in the range of 1 to 1000 kilometer. So the very first option you can see 30 kilometer to 400 kilometer. It is in the range of this 1 to 1000 kilometer. After 1 there would be somewhere 30, and after 30 there would be somewhere 400, which is below the 1000. So this particular option is correctly fitting. Let's see the other options. 500 meters, so that is below the 1 kilometer, so we cannot select that. It is wrong. 1 kilometer to 2 kilometers. Now this is in the range, but the first option is covering the broader range, and the C option is covering very small range, and that is also in the very initial zone of the mesoscale. So selecting the C option is, as compared to A option, is not that much correct. So another thing we have to reject here, because this is in the very narrow range and the very initial range. Then we have 100 meter to 1 kilometer. So this is also not in the range. This is micro scale range. So this is also not true. So only the very nearest possible answer in this particular case would be 30 kilometer to 400 kilometer. I hope this is clear to you all. That's why we are not selecting the C option, because that is in the very narrow range, and that is also in the very initial side of this mesoscale motion. So the better option here for the right answer would be the A option, that is in the range of 30 kilometer to 400 kilometer.